The first formula we're going to be doing with our lens calculation is called the thin lens equation. It looks like this: 1 over f, and f stands for focal length, equals 1 over di. D stands for distance, I is for the image. So DO is D is distance, O is object. So you can figure out the focal length of a lens if you know the distance of where the image formed and the distance where the object was in relation to the lens or the mirror. You can also, if you know the focal length, find DI if you know the DO, or if you have the focal length and the distance of the image, you can solve for DO. We will only ever solve for one variable at a time. Okay, F is focal length, DI is distance of the image, and DO is distance of the object. Now, in these equations, the sign matters, whether it's positive or negative. So when we wrap up this unit, you guys will have a formula sheet. I will give you all of this. The DI, if it is a real image, will be a positive value. If it's a virtual image, it will be a negative value. So we have to read our word equations very, very carefully. If it says it's a real image, DI should be positive. If it's a virtual image, DI should be negative. With focal length, if you're working with a converging lens, or sometimes it's called convex, so it's bulging out in the middle, the focal length will be positive. If you're working with a diverging lens or concave, so it's thinnest in the middle, your focal length will be a negative value. If you guys want to write somewhere on there, DO is always positive. The distance of the object is always measured in a positive value from the object to the lens. So it doesn't matter if our object is on the left side of the lens or the right side of the lens, the distance from the object to the lens is always measured in the positive value. Okay, so maybe jot that down somewhere. DO is always positive. Okay, so that's kind of the background to this equation. Now let's see how this works. So grab your calculator there, keep it handy. This first question says, a converging lens, so that's also called convex, has a focal length of 17 centimeters. A candle, that's the object, is located 48 centimeters from the lens. What type of an image will be formed and where will it be located? Just like in math, I want you guys to write down what is given to you first, then start calculating. So what is 17 centimeters? Guys, this will go a lot quicker if you just unmute and talk, okay?
The focal length.
Focal length. Thank you, Stephanie. Now, we need to just determine, is this a positive or a negative value? So go back to right above those formulas. Converging lens, is the focal length positive or negative?
Positive.
Positive, okay. So check, F is a positive 17. What is this 48 centimeters? The candle is located at 48 centimeters.
Distance.
Distance of?
The object.
Object. And is this going to be a positive 48 or a negative 48?
Positive.
Good. DO is always positive, so that was a trick question. What are we solving for?
Where the image is located.
Very good. We're solving for DI. And don't worry about what type is it. We'll enter that after we solve for DI. So I'm just going to write down my formula. 1 over DF equals 1 over DI plus 1 over DO. And I'm just going to put my numbers in. 1 over 17 equals 1 over DI. I don't know DI. Plus 1 over 48. Don't worry about the fact that it's a fraction right now. Okay, we'll take care of that here in a minute, and I'm going to show you guys some shortcuts in solving this equation. This is my variable, DI. How do I get rid of this? The fact that fraction, a 1 over 48, is added to my variable.
Do you flip it, maybe?
I'm not going to flip it. Melody, what do you think?
Could you move it to the other side and subtract?
Perfect. So you're isolating for a variable. This is going to feel a lot like basic algebra here. I'm going to subtract the 1 over 48 over to the other side. Okay, so I have 1 over 17 minus 1 over 48 equals 1 over DI. On your calculators, I want you guys to do 1 over 17, take away 1 over 48. If you have the fraction button, the one that looks like the square, the line, and the square, please use that one. It's going to make this formula quite easy. If you don't have that one, you can use brackets and do bracket 1 divided by 17, close bracket minus open bracket 1 minus 1 over 48. If you have the ABC fraction button, you can do that as well. We're going to have to play around with how do we use our own calculators. Try it and put into the chat, what do you get when you have, and leave it as a fraction for now. If your calculator gives you a fraction. Actually, throw into the chat whatever your answer is, regardless if it's a fraction or decimal. When you do 1 over 17, take away 1 over 48. Okay, so a whole bunch of you guys had either 31 over 816. Just gonna write that down for a second. Or you guys got that as a decimal, which is totally okay. So 1 over 816. Or you had that as 0.03799, so on and so forth. Keep the whole decimal in there, please, guys. Okay. Guys, look at your equation for a second. That isn't DI, that's 1 over DI. When you look at this equation, where we're at right now, what's your gut instinct? How do you think you should solve for DI?
Would you move like the 1 over?
And how would you? Okay, so Kira's saying we definitely need to get rid of the numerator. I have a 1 in the numerator. Often when students look at this equation, they think, I'm going to cross multiply. You can do that, but if you cross multiply, you're going to have to multiply and then you're going to have to divide before you isolate. But you guys, you know an algebra rule. Finish the statement. What you do to one side of the equation,
You do the other.
you do to the other. So what if I just flipped this fraction upside down? That would mean I have to flip this one upside down. What I do to one side, I'd have to do the other. So I'm going to invert both of my fractions, and let's see what that does. Let's see if that makes my life a little bit easier. So if I flip 1 over DI upside down, I get DI divided by 1. But what's DI divided by 1?
DI.
DI, perfect. So if I just flip them upside down, and then I do 816 divided by 31, that is going to be DI. So you can just enter into your calculator 816 divided by 31. If you have a decimal, hold on for 1 second. Just pause. I'm going to show you how to do that. What is 816 divided by 31? And give it to me as a decimal, let's say 2 decimal places.
26.32.
Perfect, 26.32. And this was in centimeters. Okay. If you got a decimal right here, this is the same thing as 0.375.99, so on and so forth, over 1. So when you flip it, you would need to do 1 divided by, and I want you guys to use your answer button. So that way you don't have to re-enter the decimal because you might make a mistake. So do 1 divided by the ANS button on your calculator. Lila, what do you get when you do that? Did you find the ANS button? Not sure what happened to Lila. If you do 1 divided by your decimal, you'll actually get the exact same thing. Anybody having trouble finding the ANS, the answer button? How do I know if this is a real or a virtual image?
Isn't it, I think, virtual because it's a positive?
So you're
number?
definitely going off of whether it's positive or negative. So look here in this information. If it's a positive DI, what is it, guys?
Real.
Real, awesome. So this will be a real image because it's a positive DI. So if you want to add that on your note, a positive DI tells you that it's a real image. If you end up with a negative, it means it's a virtual and it's forming on the same side of the lens as the actual object. So this is a real image. Okay. Don't worry, we're going to try another one of these. Questions before we try number 2? All right.
How do we find where it's located?
We just did. It's located here at the DI. This is the location.
Okay.
Like that's like the location like on the horizontal line.
Yes, yes. Okay, let's try this one. A diverging lens, so it's a concave, it's going to be thinnest in the middle, has a focal length of 29 centimeters. A virtual image of a marble is located at 13 centimeters in front of the lens. Where is the marble located? You guys are probably like, well, we would know that. We would have put the marble down. That's true, but let's see if we can also calculate it. What is this number 29? Let's identify our values here first. Focal length. Now, it's a diverging lens. So is this going to be a positive or a negative 29?
Negative?
Very good. Focal length for a diverging lens is negative. A virtual image of a marble is located at 13. What is the 13?
The DI?
The DI. Okay. It says it's a virtual image. So is this a positive or a negative 13?
Negative.
Very good. And what are we solving for?
Object distance.
Distance of the object. Okay. So we're going to plug in all of our values. And we're going to solve. So 1 over F equals 1 over DI plus 1 over DO. All right. Plug in your numbers. Okay, let me try to catch up to Kira then. So 1 over negative. Okay, careful with your signs. This is a little bit of a tricky one. All right, who wants to tell me how am I going to isolate for my variable, which is DO? How do I get rid of this fraction?
Would you move it to the other side?
Good, and what's going to happen to it? It's a negative fraction. So what happens when I move it over the equal sign?
It becomes positive.
Becomes positive. Good, so be very, very careful with your signs. So I'm going to have 1 over negative 29 plus 1 over 13 equals 1 over DO. Again, just use your fraction button or brackets, ABC button. Also, your ABC button may be a little tricky with this one. If it won't let you do 1 ABC negative 29, let me know. We might have to put the negative with the 1. But if you have a negative in the denominator, the whole fraction is a negative. So you could put it out front, you can put it in the numerator, but you're going to have to be comfortable with your calculator. Okay. So let's see what we get here, guys. Okay, so a whole bunch of you guys have 16 over 377. As a decimal, you would have had 0.04244, and it goes on and on and on. Okay. Remind me again, how are we going to isolate for DO?
Flip the fractions.
Fantastic. So just flip the whole thing upside down and do 377 divided by 16. 377 divided by 16. Stephanie, what did you put into your calculator that it gave you an error? But when you get DO, it should always be a positive value. So if you end up with a negative, go back and read the question carefully. Make sure focal length is negative because it's a diverging lens. DI is negative because it said it was a virtual image. Okay, so be very, very careful and intentional when you're reading the question. And we should have got 23.56 centimeters.